Howdy, this video will go over graphing quadratics in Vertex form. So let's go ahead and get started. We're going to go ahead and go over number 2 first, and then 6b and 7. So for number 2, we're given f of x equals negative x minus 2 squared plus 4. We now need to find the vertex. So remember that the vertex is going to be hk, where h comes from the opposite of the inside of your square, so that would be positive 2. And then the outside is the same number, 4. 2, 4. Then your axis of symmetry is going to be x equals whatever you got for h, so 2. Now direction is going to be which way does the graph open? Does it open up or open down? Since we have a negative function, the negative here, that means it opens down, so the direction will be downwards. Now, if I asked you if it was a maximum or a minimum, then you would go ahead and say it was a maximum because your vertex is going to be the maximum point on your curve. Okay? So if it's a negative function, it opens downwards and it's a maximum. Zeros, domain, and range you can't find until you graph your function. And you can't graph your function until you have your table. So let's go ahead and fill out our table. Usually we put 0, 1, 2, 3, 4, and negative 1, negative 2, negative 3, negative 4. But this time we're not going to do that, because if we did that we would not get a perfect picture of our graph. In order to get a perfect picture of your graph, we need to put the vertex at the center of your table. So go ahead and put 2, 4 at the center of your table, and then fill out the rest of your x values. So 2, 3, 4, 5, 6, 1, 0, negative 1, negative 2. Now, to find your y values, all you're going to do is plug your x values into the x of your equation. So, doing that, let's go ahead and plug in 6 first. So, 6, plug it into here, will be 6 minus 2. 6 minus 2 is 4, and then 4 squared is 16. And then that'll be negative 16 because of that negative. And then negative 16 plus 4 is negative 12. So put negative 12 right there. Now plug in 5. 5 minus 2 is 3. 3 squared is 9. The negative makes it negative 9. Negative 9 plus 4 is negative 5. Now plug in 4. 4 minus 2 is 2. 2 squared is 4. That makes it negative 4. Negative 4 plus 4 is 0. Last, plug in 3. 3 minus 2 is 1. 1 squared is 1. That negative makes it negative 1. Negative 1 plus 4 is 3. Now, the top part. Just kidding. The top part's really easy. So, with our graphs, we have a U, and we have a vertex. This side here, give us one side. The other side is reflected across the vertex. And we're going to do the exact same thing for the values. We're going to reflect these values across the vertex. So 3 will go there, 0 will go here, negative 5 will go here, and negative 12 will go here. And look, we have a rainbow now. Isn't that cute? Alright, color rainbow. Okay. Now we have our points. Let's go ahead and plot those points. So plotting negative 2, negative 12 won't fit because we have a 10 by 10 graph, so ignore that. If you can't graph it, ignore it. And then negative 1, negative 5, 0, 0, 1, 3, 2, 4, and then the other points. So now go ahead and connect your dots, and there's your graph. Now we can find your zeros and your domain and your range. Your zeros will be the same thing as your roots, or your solutions, or your x-intercepts, which are going to be here and here. That's where they cross the x-axis. So those two values are going to be 0, 0, and then 4, 0. 0, 0, 4, 0. Now your domain is going to be left to right. So we have arrow to arrow, which means negative infinity to infinity. Range is from bottom to top. So your bottommost number is negative infinity. Your topmost is going to be 4. So your range is negative infinity to 4. Now, circle the values in the table that represent the zeros of the function, this part right here. And, well, zeros are 0, 0, and 4, 0, so 0, 0, 4, 0, done. Now, part 2, the second bullet, circle the values on the graph that represent the zeros of the function, which we already did. We circled the values on the graph that are the zeros. Now we need to describe the transformations that occur to the parent function to produce the graph. So this part right here. So look at our function. We have a negative on the outside, and that means it reflected across the x-axis. Reflected across the x-axis. And then the negative 2 on the inside means that it translated 2 units right. And then the plus 4 on the outside means and 4 units up. So reflected across the x-axis, translated 2 units right, and 4 units up. Now this next part is exactly from our notes. We're going to write the function in standard form. So let's go ahead and rewrite our function. So y equals negative x minus 2 squared plus 4. And now we're going to go ahead and convert that to standard form. So converting that to standard form, we have our square here, meaning to convert that we need to split up that square. So bring your negative over, and then x minus 2 times x minus 2, and then plus 4. Bring over your plus 4. So we split up the square. Now the next step is we need to distribute the first binomial into the second binomial. So that's going to equal negative, because we're not dealing with the negative yet, so negative parentheses. X times x is x squared. X times negative 2 is negative 2x. And then negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Parentheses. And then bring over your plus 4. Now we need to distribute this negative to the inside of our quadrinomial. So distribute that negative. So when you distribute a negative, that means your signs change. So positives are negatives and negatives are positives. So you'll get negative x squared, and then plus 2x minus 4, and then bring over your plus 4. Now your last step is to combine like terms. So combine your x's and your remainders. So you'll get negative x squared, and then 2x plus 2x is 4x, so then plus 4x. Negative 4 plus 4 cancels, so that's it. There is your standard form. Now, moving on. Oh, let me reiterate something. No, go ahead and make that scratch out that 2. Make this less complicated, less hard for you. No fractions, just negative 3. So, but for this part here, what do I always want you to have in the center of your table? The vertex. So we need to find the vertex of 4, which is the opposite of that. So positive 3, same as that, 6. So all we do is plug in 3, 6 into your table right there. Now just fill in the rest of your x values. So 3, 4, 5, 6, 3, 4, 5, 6, 7. Wait, 3, 4, 5. Okay. And then negative 2. Oh, shoot. 2, 1, 0, negative 1. Oh, yeah, okay. I just want to check something. Okay. Okay, so that's it for number 4. Well, what I'm going to help you with. Go ahead and fill out the rest of that. Now, last 2, I'm going to do 6b and 7 with you. So 6b, we have write an equation for the graph of h in the form h of x equals a times x minus h squared plus k. So this is vertex form right here. Vertex form, meaning we need to find the vertex in order to make our equation. So the vertex of that graph is going to be negative 4, 4. So go ahead and put that right here. Negative 4, 4. Now, go ahead and plug those into your function. So we can have h of x equals x, and then remember, this part here is going to be your h, but it's going to be the opposite of what you have, because it's on the inside. So since we have -4 here, this will be x plus 4 squared, and then same as the outside, so then plus 4. Now I am missing some things. I'm missing a, and also the graph is facing down, so it's going to be a negative function, so put negative right there. Now how the heck are we going to find a? Because we have an a right here that we don't have. That's x. A. Okay. The a is really simple to find. You're gonna get your vertex, which is right here, your vertex, and then find the next vertical line. So right here. Ask yourself, where does our graph cross that vertical line? It crosses it right here. So the distance between this point and this point is a distance of 1. So a equals 1. Now let's say that it crossed right here instead. That means that a would be, from your vertex, 1, 2, and a half. So that would mean a would be 2.5. But for this graph, a equals 1. So just put -1 times x plus 4 squared plus 4, and that's your equation. Last one. Looks difficult, sort of, but it's really not. It's quite simple. The graph of the function g, so this graph right there, was obtained from the graph of the function f using the transformation. So based on the graph, write an equation to describe g of x in terms of f of x. Pretty much, it's just asking what happened between here and here. What happened? So we can see that it went 1, 2, 3, 4, 1, 2, 3, 4, 5 left. So left 5, and it went 1, 2, 3, 4 down 4. So now let's write this in function notation. F, x, leave a space. Since it went left 5, what's going to go on the inside of that space? Plus 5. And since it went down 4, we're going to have a -4 on the outside. Okay, that's it. So thanks for watching. Make sure to finish this before Monday and turn it in. Okay.